Hi lads, in this video I'm going to go through some basic instructions for a DCG. First one I'm going to look at is bisecting a line. So very simply, just draw a line of any length. What you do then is you take your compass and you take a distance on it greater than halfway. So you can see there that's obviously greater than halfway. And you're going to swing an arc above and below. And then keeping that distance, go from the opposite end and swing an arc above and below again. Where they cross, you can see there, form an X, join those together, and that bisects that line. We'll just call it AB into two equal parts. The next one then we're going to look at is bisecting an angle. So to bisect an angle, just take a line. Just take an angle there, any angle at all, and it's going to bisect this one here. So once again we get our compass, take any distance on our compass, and from that point there, I'm going to swing an arc there and there. All I need to do there is extend the compass, swing an arc from the 2 points you just created. So there and there. Just extend it a bit more, and you see where they meet at this point here. Join that back to our centre, and that bisects that angle in two there, giving us two equal angles as a result. The next one then we're going to look at is dividing a line into a number of equal parts. Let's just say we have a line there. Let's call it AB. I want to divide that into, say, 5 equal parts. Take a line at any angle from A. What we do is we step out a number of times in relation to the line. So for this one we want to do 5. So I take a distance on my compass and I step out 1, 2, 3, 4 and 5, and just label them as well, 2, 3, 4, 5. So we can tell there, from there to there, that line is perfectly divided into 5 equal parts. And what we want to do is we want to move that to make this line AB into 5 equal parts. So we get our two set squares. We join 5 to ends of the line because that's where we want 5 to end up. And using sliding set squares, we move 4 up, 3 up, 2, and finally 1 there. They're all parallel, and B can be 5 there too. And we divided the line AB into 5 equal parts. If we want to do any more, we'd add 6, 7, 8 for example. So say we had 8, we connect 8 back to there, changing that to 8, and using sliding set squares we divide the line up once again into 8 equal parts instead. The next thing we're going to look at is to divide a line into a given ratio. So say for example we had a line here. Just call that AB again. We want to divide that line into a ratio of 5 is to 3 for example. So what we're going to do is the exact same as the last method. We're going to take a line out at a random angle, and we're divided as a ratio of 5 to 3. So we add the two together, so 5 and 3 will give us 8. So I'm going to step out 8 equal distances here. So 1, 2, 3, 4, 5, 6, 7 and 8. And once again just label them 1, 2, 3, 4, 5, 6, 7, 8. I just use my t-square this time as my second sliding set square. slide it up to 5. And there we have, that is in the ratio of 5 is to 3. So that distance there is 5 is to 3 now. Because we've got 1, 2, 3, 4, 5, and we have 3 left over, 6, 7, and 8. And that divides that line up. The next thing we're going to look at is in relation to triangles. So circumscribing a circle about a triangle. So what I'll do is, I'll just draw a triangle there. Any side lengths. And to circumscribe, that basically means we're going to have this triangle fitting in the center of it. So basically all of these lines are going to be chords in relation to the circle. So to do that, what we need to do is, if we're treating these like a chord, if we bisect any two chords, they're going to pass through each other at the center of the circle. So if I take a line greater, or a distance greater than halfway, swing an arc there and there, swing an arc there and there, somewhere along this line here, which is bisecting that line there, is going to be the center of our circle. So somewhere along that line. To find exactly where it is, we bisect another line. For example, this one here, or this one here. I'm just going to go for this one. So once again, taking a distance greater than halfway, swing an arc each side, and connect two x's together again. And you can see there where that line intersects this line, that gives us the center of our circle there. And all we need to do now is stretch our compass out to that point there, and it will pass through our center there. Sorry, not our center, through our 3 points on our triangle. So you can see there we have a chord, a chord, and a chord, and we know if we bisect two chords, they'll pass through the center of our circle there, and there we have circumscribed the triangle there. The next one then is to inscribe circles. We want to put a circle inside a triangle. So let's draw my base there. Just take a line and angle here, and just take a line there. For this one, what we need to do is we need to bisect any two angles to find the center of our circle. So the base angles there, I'll bisect them too. So extend the compass, swing an arc there and there. That'll give me one line there. So somewhere along that line is going to be the center of our circle, and the same on this corner here. So you can see they cross there. That's going to be the center of our circle. And to guarantee we need to know exactly where we're going to be stretching our compass out to, what we do is we draw a normal. Because we're going to treat these as tangent edges, because they're all going to be in contact with the circle, therefore they're going to be a tangent. So a normal is always drawn perpendicular to a tangent. So because it's a horizontal line, if I draw a vertical line here, that'll give me my radius. If I go perpendicular to here, it'll also give me my radius. Perpendicular to here will also give me my radius. So I already have one there. So what I can do is I can stretch my compass out to there, swing an arc around, just make sure get it all the way around there, and then finally the last little bit It's a bit messy. Just a hole in the page. So just get it all the way around there and around to there. And that's inscribed then. And if I just show where my tangent line occurs, there's my tangent line by looking perpendicular to my outer set square. There's my center. There's where my point of contact will be there. But same idea with this side. I just take that edge there, go from my center. That would be my tangent point there. And there are some basic construction methods that we would use in DCG. So hopefully that video helps.